Hey guys, Russ here with BlueLine Wood Flags, BlueLine CNC. I'd like to welcome you to the channel and welcome to another video. I've been noticeably absent and I apologize for not producing content recently. This is the first video in a long time that I've been able to push out. And I'll save the reasons for that for another video, but suffice to say, we're here today and we've got a good one for you. If you are into 3D modeling and making your own parts on a 3D printer and you're into lasers, then you have come to the right place, because today we're going to be specifically making a part for our Xtool RA2 Pro. What the RA2 Pro is it's a rotary tool attachment for the laser device, and it allows you to engrave on cylindrical objects such as tumblers, wine glasses, rings, anything that's cylindrical. Basically you can attach to this RA2 Pro and you can do your engraving on it. And what we're going to be making is a part that attaches to the RA2 Pro, which basically keeps your cylindrical objects in place and uptight and perpendicular to the chuck, and also allows quick batch processing. And what it looks like, and you may have seen these out there, is this right here. It's just basically a 3mm disc that has this design cut out in the middle that allows for the chuck jaws, the jaws of the chuck, to slip into and expand and contract and move. And what it does, let me get a little bit closer in front of the microphone here, is say you've got a tumbler that you want to do an engraving on. Well, basically this is on the chuck itself, and you mount it on this perpendicular, and it takes away the guesswork. You don't have any gaps that might affect your engraving. So as long as you push this on your chuck jaws and all the way up to this backplate, or backstop as they sometimes refer it, you know that this is going to be on perfect, and you'll get perfect engravings every single time. So let me put this down or it's out of the way. And so, like I said, we're going to be using a program called FreeCad. FreeCad is a parametric modeling program. There's other ones out there. There's Fusion 360, there's SolidWorks. I happen to like FreeCad because, number one, it's free. It is open source software, so that's what makes it free. You can do a whole bunch of stuff with it. You can do assembly work, 2D drafting, you can do architecture, a whole host of capabilities that this software basically allows you to do. But we're going to be using it for simple part design. And let me go ahead and fire it up so you can kind of see it in action here, and we'll get going on it. So I've got it up, and we'll go ahead and include myself in the lower right. And this is what the screen looks like that you're greeted with when you first fire it up and open it up with. And you may have a section here, if you've been working with it for a while, called Recent Files, and it'll show some of your recent files that you can select from and continue working on. But this is the default if you have never opened it up before. And what we're going to be doing is, like I said, we're going to be creating this part that I showed you. And what I like to do is start off with an empty file on all my creations. So I'm going to come up here where it says empty file, and I'm going to click on that. And it gives us this blank canvas to work with. So now that we know that we have a blank canvas, we have to create a body. We can't just leave it unnamed and start working on something. In order to create any type of three-dimensional part, we have to start off with a body. And that icon is right up in here in blue. So we're going to go ahead and click on that. It says Create Body. Now we can get going. And you can see what it's doing is it's starting to build a tree over here in the Model tab of your tasks. So come over here to Create Sketch. Everything is based off of a sketch, and then we create our three-dimensional items, our elements to the part based off of sketches. So the first thing we want to do is create a sketch. We'll click on that. And we're presented with another screen here that's telling us, hey, you need to select a plane that you want to work off of. Now remember, this is a parametric design program, as I said previously, and it operates in 3D space. It's looking to, and it's asking you basically, well, where do you want to create your part? How do you want to create it? Well, I find it easier to oftentimes select the XY plane and work off of that. It's like working off of a piece of paper or something that's laid down flat in front of you. So that's what we're going to select here for this part. And we'll go ahead and we'll select OK after we've highlighted it. And it gives us two axes. I don't know. What's the correct word? You guys tell me. And this green one here is the y-axis, and the red line is the x-axis, and this little blue dot here in the middle is where the two axes intersect and meet. So what we want to do first is create our circular excuse me, pattern to coincide with the outer dimensions of this disc. So let's go ahead and select Create Circle by Center. And now you see those little crosshairs flying around there in the middle with that little red circle next to it. We're going to take our little crosshairs and we're going to bring it all the way over that blue point right there where it says 0, 0. That's our dimensions. If we go anywhere off in the work plane, you can see those dimensions change accordingly with where you're at in space. But we want to be right on that blue dot to where it says 0, 0, and we're going to click once. And that allows us to put in a numeric value. Well, you've got to take measurements, or you have to know your measurements of the part that you want to create, just like anything that you do in 3D printing. I know that this part that I want to make is 4.3 inches in diameter. So I'm going to type in 4.3 and hit enter. And now I have this green circle. Why is it green? Well, it's green because it's fully constrained. Why is it fully constrained? Well, it's fully constrained because I've told it at what point in space it needs to be, which is right here in the right here in the center where the x and the y-axis meet, and I've also defined its diameter. And now that I've defined its place in space and its size, this circle basically can't be changed at all. It's totally constrained. I could change it if I want. I could change the diameter and but still make it constrained. Without going into too much detail, basically just keep in mind that anything you do in a parametric 3D CAD design program, any element you create has to be fully constrained. And if it's not fully constrained, your design process is not going to work. So I have a constrained circle. It says fully constrained over here in the solver messages. It's green. I'm good to go. So I'm going to select close. So now we still have this green ring on our computer screen, and we need to give it some 3D body. We need to give it some substance. We need to give it some dimension. And how do we do that? We need to use a tool called Pad. And that's over here on the far left. And you can see it just simply says Pad a selected sketch. So we're going to select Pad. Now you can see we have some dimension to it, some substance. Well, that dimension is set at 0.39 inches, which is far too big for what we want. So we need to bring that down to our selected size. And we want something that's 3 millimeters thick. Well, we're dealing in the inch world here, 0.39 inches, so we have to do a conversion. And what's good about FreeCAD is you can work in millimeters if you want, or you can work in inches. You just go into the preferences and you set which environment you want to work in. I just happen to be in inches right now. So that means I have to do some conversions ahead of time, which is okay. I just use the Google conversion, millimeter to inch conversion, or inch to millimeter conversion as necessary. And I happen to know that that is 0.11811. And it doesn't have to be that infinite. You can even take it down to 0.118. Same difference. We don't have to be that precise. So let's go ahead and hit enter. And you can see what it did is it brought that thickness down to 3 millimeters thick, roughly 3 millimeters thick. So after we get our pad to the thickness that we want, we need to do the cutout to create that cutout, that Y. And how we're going to do that is we're going to create a rectangle, and then we're going to do a polar, it's kind of like a polar copy or an array copy, as you'll see here quickly, based on a 360-degree angle. So let's click on the surface that we want to create this rectangle, and we're going to be using a pocketing operation for that. So we're going to come over here and we're going to create another sketch, and it brings our axis back, and we're going to come up here to select to create a rectangle, and let's click and drag one out a little bit. Whoops. And I know my first measurement that's highlighted up there for the thickness, or the width rather, is going to be 0.335 of an inch. And then let's tab over to the next field and hit 1.55 of an inch, or 1.55 inches. Now we need to position it correctly on top of this disc, and because right now it's over here in space. We need to get it over here to where we can pocket it out. So let's go ahead and hit escape and get out of rectangle creation mode. And in order to move this and position it correctly, we need to get rid of this degree of freedom right here, this one here. That'll allow us to move it and set it in place where it needs to be. So let's go hover over it to where it turns blue, hit right click and just hit delete. Now we can move it around wherever we want, because the way it is right now, if we didn't remove that, we wouldn't be able to position it properly. So let's click this point, and I'm not holding down control or anything like that. I'm just clicking these points. And then let's click this axis over here. And now everything that I've clicked on is green. We want to select constrain symmetric. So we'll click it, and you can see that rectangle move over there. And now it's symmetrical both on the left side of the y-axis as it is on the right side of the y-axis. Well, if you look over at your solver messages, it still says that we have 1 degree of freedom and that we're basically not fully constrained yet. So how do we know? Because we can select this rectangle and we can move it up and down. That is our 1 degree of freedom that we have to remove and get rid of. I can't go side to side, as you can see I'm trying to, but it's fixed to that y-axis. But we have to solve this 1 degree of freedom right here. So how do we do that? Well, the way I do it is I come over here to this point here on the rectangle, this lower left point where this line and this line meet, and I click on it. And then I come down here to the x-axis and I click on that. And now we have a button that will work for us called Constrain Coincident. So let's click on that. You can see it brought that rectangle down in line to where that lower line of the rectangle is in perfect alignment with the x-axis. It's green, the rectangle is green, and if we look in our solver messages, it says it's fully constrained, which is exactly what we want. So let's close that. And now what we need to do is we need to pocket it out. So let's come up here to the pocket tool and let's click on it. And let's just make sure that it's through the entire thickness of the material. And you can see what it did is it took that rectangle and it pocketed it out, pocketed it out of the circle. So we have this one rectangle that's basically cut through. So we can select OK now that that task is complete. And let's select our pocket, because that pocket is where we're going to create our array of 2 other ones for a total of 3 rectangles. You'll see this will make sense in a second. So let's select pocket, and let's come up here to polar pattern. That's what FreeCAD names their array copy, is a polar pattern. So let's click it. And as you can see, by default, we get 2 occurrences on a 360-degree angle. Your 360-degree angle is the circle itself, and your 2 occurrences are a rectangle here and a rectangle here that are basically joined together on the x-axis. Well, we want 3. So let's go ahead and change the occurrence from 2 to 3. We can just either change that numeric value or we can just use these little arrows over here. So I'm going to just bump it up from 2 to 3, and you can see now we have the Y pattern that we're looking for, where this will fit on the chuck jaws of the RA2 Pro perfectly. So let's go ahead and select OK, since that task is complete. And what I like to do next, and this is just me on a part like this, you don't have to, it's totally optional, but when handling it, we'll just make sure that all the sharp edges are eliminated and it's nice and smooth to the touch. So let's go ahead and select this edge and then hold down Control while we select all these other edges here. And you guys probably know what I'm going to do is, whoops, yeah, I wrecked that. There. No, I messed up. Let's start over. That one, let's hold down Control, that one, that one, that one, that. Kind of finicky, so you got to be careful what you do when you start making selections. So I've got all these edges that I want to do something with, so they're not short. Well, I'm going to use an operation called fillet. So I'm going to come up here to fillet. I'm going to click it, and by default, you can see it goes to 0.04 inches. I think that's a little too much for what we're trying to do here, so I'll knock it down by half, 0.02. When I hit enter, you can see that fillet change. The radius, basically, the diameter is not 0.04 any longer, it's 0.02. Now let's go ahead and turn the part over. So let's go up to our cube in the upper right and click there. Now we have access to all the bottom edges. So let's go ahead and select this edge. Again, hold down Control and click on all these other edges. When they turn blue, you can click on them and select them. Make sure you don't do what I did the first time around and select the actual surface of the part. Make sure you just select these edges. And once you've got them all selected, just come up here to fillet again and select fillet. And again, change that from 0.04 to 0.02. And there we have our part. Let's just go ahead and bring it back down. Whoops, not bottom. There we go. So basically that's our part, folks. That's what we need to cut out on a 3D printer. And in order to get our file into an STS mesh file and send it to our slicer, we need to come up here to Body and click on Body to where Body is highlighted. And then we can come up here to File, Export, and export it to an STL mesh. And you can see by default it's got mine ready to go as an STL mesh. FreeCad allows you to save it in a whole bunch of different, or export it in a whole bunch of different formats rather, but we want STL for, where did it go? Right there, STL for our purposes. So, and then just make sure you name it what you want to name it down here and save it where you want to save it, which file folder, just like you would any Windows operation. I'm using Windows, or in the case of a Mac, however you would save it in a Mac. So let's go ahead and close this, and let me go ahead and go back to the different camera here. All right, so that's pretty much it for this video, guys. I just wanted to show you this part for your RA2 Pro. In an upcoming video here real shortly, we're going to be demonstrating the assembly of the RA2 Pro with the RA2 Pro accessory kit and how I'm going to position that in the Xtool S1. I have the 40-watt model, and we're going to get it all situated in there and fastened down. I'm going to show you how I do that. How I'm going to do that, rather. We'll put that on video for you, and we'll get this part integrated into the RA2 Pro, and we'll start engraving some tumblers. And I think it's going to be a pretty cool project coming up as well. So I'm going to make this file available on my website, or I'm going to give you directions as how you can get the STL file in the description down below. So if you want to just download it and print it yourself, feel free. Or if you want to get involved in FreeCAD and follow along with this video and do it the way I did it, feel free to do that as well. What's really neat about FreeCAD is if you want to design a part on your own, and it doesn't have to be for your laser, it could be for anything. Any part you need that is not something you can buy on the store shelves. It has to be custom made. You can you can do it. If you got a set of calipers and you know the measurements of the stuff that you want to create, you can make, the sky's the limit. You can just about make anything that you want that you can 3D print. So if that's something that interests you and it's something that you like, gosh, feel free to subscribe to the channel if you're not already a subscriber. And I urge you to hit the bell icon to be notified when I post new content. If you are a subscriber, I thank you guys very much. I really appreciate it. And we'll see you on the next video.